Hi Jake,
Hi.
thank you for being in PyCon Colombia, and
Yeah.
congratulations on your keynote. It was very enlightening.
Yeah, thanks. It's really good to be here.
So let's jump in. A lot of people are aware from you from the books you wrote, many conference talks you have been given, your blog posts.
Mhm.
So would you like to share a bit about the person that probably most of us are not aware, like where you grew up, what you did, when you were growing
Yeah.
up, maybe your studies, bachelor and all that.
Yeah, so I actually grew up in Palo Alto,
Oh.
and kind of in the middle of it all. And Palo Alto was a very different place in the '80s than it is right now. But yeah, my dad was a scientist who worked at Hewlett Packard, developing kind of the material science behind inkjet printers. So I was always kind of in that sort of hardware tech world. But yeah, I was into sports and all sorts of things growing up, and I never actually really got into programming and computers much when I was growing up. That wasn't until actually after college.
Okay, so now that you mention it, so when did you first start in coding? What language was it? Was it to
Yeah.
solve a small itch, or was it an assignment?
Yeah, so I first I took a C++ course when I was in high school. And then, I found it kind of interesting, but I didn't really do anything with it after that. I didn't do any coding through college or after, but it was when I started my graduate program in astronomy, we were starting to work with data, and I needed to learn how to do it. And I had a professor I was working with who told me that Python was a good language to learn, so I kind of jumped in and started working on it.
Great. So
Yeah.
So when you first started using Python, like what was it specific? You remember what you were doing? Was a small
Yeah.
script or some data analysis? What was it?
Yeah, I was doing some data analysis for the Sloan Digital Sky Survey. We were working on we were working on analyzing supernova data to try to characterize dark energy. And the first sort of things I was doing was just data cleaning and moving things around, taking hundreds of files in a directory structure and condensing them down into a single thing that we could feed into I think it was a Fortran program at the time. Yeah.
Yeah, I mean, working in astronomy, well, that's your field basically.
Mm-hmm.
You have a lot of data everywhere, so it's ripe for cleaning
Yeah,
and
yeah,
for processing.
and the data challenge there is just getting bigger and bigger with time. There's this large synoptic survey telescope down in Chile that's going to be turning on in the next year or two. I'm not involved as much anymore, but it's going to be something like 30 terabytes of data every night for 10 years, and trying to figure out what to do with that. So I was working, my PhD advisor is someone who's closely involved with that project. So the big data aspects of astronomy have always been something that I've been interested in looking at.
That's very interesting. So now that we were talking about Python and astronomy, like how big or how different do you think the field of astronomy would be at the moment if it weren't for the Python language and the influence in it?
That's a good question. And so when I started in astronomy, the main language people were using was IDL, which is kind of a scripting language built on Fortran that has it's proprietary, so there's a license fee involved with that. And there was a really big effort to kind of create a community repository of IDL programs, and I think people started realizing that the licensing fees and the non-openness of the language that a lot of the tools were being built on was a problem. Especially if you start. If you're at a big university in the U.S., they can generally afford the licensing fees. Yeah. But there are a lot of astronomers around the world that don't have the kind of resources to use those sorts of expensive tools. So I think as the astronomy field started moving towards Python as kind of a fully open way of doing this work, and really opening the doors to people who otherwise wouldn't have an opportunity to be involved.
Yeah. We have similar issues here. I mean, in academia,
Yeah.
it's pervasive because they get free academic licenses, and
Yeah,
then they go out to
yeah.
the industry or work life, and I don't have the tools.
Yeah, and one of the
But
big things is I was starting to work on Python and astronomy. The thing that I noticed is that, you know, when students finish an undergrad degree or a graduate degree in astronomy and they are proficient in IDL, there's not a lot of job opportunities for IDL. There's not a lot of people using it, but Python is completely different. You know, if you become proficient with Python through the course of your graduate career, you know, you might go on to be faculty and do the academic track, but there's increasing numbers of students who are not doing that, and I think getting them proficient and to become experts in Python really serves them well in their career wherever it takes them.
have you seen like this is something I've seen personally, like there is you can see the difference between moving this from proprietary software to more an open software, and there is also like kind of an age gap, like older professors or in higher positions are more reluctant to switch gears, and it's understandable, but have you also like seen this, or is this something that you have started to notice that is changing?
Yeah, it's difficult. I mean, I don't want to drag on old professors. I'm getting old myself, and I don't want to learn a new language, right? I'm just lucky that Python seems to be, you know, still popular right now. But yeah, it's hard when you've done something the same way for a long time. It's hard to change, and we have seen a lot of in the astronomy field. It's been coming from the younger students, younger faculty, younger postdocs that are pushing kind of new tools. And the real thing in the Python community that has enabled Python to take over is this AstroPy consortium. So AstroPy is an open source project to kind of support all the basic things you need to do in astronomy in Python.
Taking care of units.
Yeah, units and file formats and some kind of esoteric statistical models that astronomers like to use, and all sorts of things like that. And it's been a huge, I've kind of been tangentially involved. I've had a few contributions, but it's been a huge effort by some folks at the Space Telescope Science Institute and others that have really made that happen, and it's great people to work with. Have
you recently contributed to the project, and what was the contribution about?
I did a small pull request last week.
Oh,
so
great.
Yeah, it was added methods to one of these statistical models to kind of dig into the model a little more and reason about what's going on with the data in the model.
So now that we have covered all this, there are huge fields now that are amassing huge amounts of data, and there is a new, the big data revolution kind of had like very big impact the past years, but right now we're into the machine learning, the artificial intelligence, neural networks everywhere, and we need huge amounts of data. Like, have you seen like missing opportunities in the astronomy field where none of these tools have yet had the impact that they are having on other fields?
Yeah, that's hard. So astronomy is a little bit different than a lot of fields in that often the astronomy data that we have a very good idea of what the underlying physical model is. You know, if you're looking at a star, you sort of know the physical processes that generate the light from the star. And you know the physical processes where the light goes through the optics of the telescope and how that renders in the CCD and in the resulting image. So it's been my observation that things like deep learning and deep neural networks, there's not been as much uptake in astronomy. I think there's several people that have been looking into various aspects of using that, but often astronomers tend to go towards these forward models that are
like
solved
not
in a
black box.
Yeah, forward models based on some physical model that then you solve in sort of a Bayesian manner, and it's really interesting to straddle these fields and kind of be in the data science world where people are excited about kind of black box models that work really well in some applications, versus the astronomy field where the black box, you want to be able to open that up and see what's going on a little more.
I understand.
And so for that reason, I think astronomers are often leaning towards these forward models, Bayesian forward models.
Do you think this will change, or probably, I mean, there is a huge field in image processing, and astronomy has a lot of images that would probably benefit from all these models trying to search for
Maybe, and there's been some interesting work. I haven't kept up with the deep learning work, but I see these paper titles come across, and so I know there's some folks thinking about it. And yeah, I should dig in a little more so I can talk about it.
Exciting things might come in the future.
Yeah.
So you write a blog post. I must admit, I'm a huge fan of that blog post. I've been reading it for a long time. I've learned a lot from the things that you write. And so, how did you come about started writing? Where does the name come from? Which I think is pretty cool. So maybe you want to share a bit.
Yeah. So I actually started the blog. I did the first post the week after I finished my PhD, and the reason is I basically I kept learning these things about programming and about various topics over the course of my PhD, and I found that after a year or so I forgot, and so I started writing blog posts just so I could remember what I was thinking about.
Okay, so a reminder.
A reminder so I could read it later, and then it got to be just a fun way to do interesting things with Python and sort of share it with the world. And when you're used to writing academic papers that 12 people read, it's kind of cool to write a blog post and see thousands of people reading it. Yeah. So I really had fun with that.
Yeah, and the 12 people reading are making corrections at the time.
Exactly.
The other 1,000 or million people reading are just enjoying it.
Yeah,
so it gives you a different perspective. Great. How did you come up with the name? I really like it.
Honestly, I don't remember. It's Pythonic perambulations. I don't remember. I just think I liked the alliteration.
Yeah, I like it too. So, getting a bit personal again. Before you told me you have 2 daughters. One is 5, and now the other one is 1, I believe.
Yeah, almost 2.
Almost 2 now. So, so you're a recognized face in the community, in Python community. You go to conferences. You're a book author. How are you managing to balance family life with this public personality that you are now?
It's really difficult, I've found, and I've cut back on conference speaking and traveling over the past year or 2 because of that. I mean, you initially invited me to come here last year.
I invited you last year,
and I wasn't able to do it. Yeah,
this is not gonna happen.
So I'm traveling much less and actually writing a lot less too, because I just find that I want to spend time with them. And I used when I wrote my book and I wrote blog posts, it was often kind of a nights and weekends thing because I had my day job and I was doing these extra things. And now my nights and weekends are full of
diapers,
diapers and bath time and bedtime and playing and birthday parties and soccer practice and it's really
any
fun.
advice you want to give to future PyCon Colombia fathers that are probably in a similar situation?
I don't know. I've since becoming a father, I've kind of rearranged my life around my family and my kids in a way that it wasn't before. So it really has changed everything, but in a way that I really like.
Glad you're happy.
Yeah.
So, your most recent endeavor in open source is related to visualization.
Yeah.
So the project is called Altair, and it's using this. I remember reading about it. It's Vega and Vega Lite, which is kind of like a specification for describing graphic entities, I believe, or something.
Yeah,
like
exactly.
That. Can you tell us a bit more about it?
Yeah. So Altair is a Python wrapper for this Vega and Vega Lite grammar that you mentioned, and what Vega Lite is it's a way to kind of succinctly express exactly what you want to communicate in a chart using this declarative language that happens to be expressed in JSON. So so you basically you have this little essentially a Python dict that describes exactly what you want your chart to look like, and then there's a JavaScript library behind that renders it. And I was really excited about this because the grammar has come out of the Interactive Data Lab at University of Washington, which is led by Jeff Hare, who he and his grad student created D3, among some other tools that people know and love. And so they thought, in putting this grammar together, they thought very deeply about what it is people want to express when they're creating charts and how you encode that in a way that's meaningful. And so you can dig into the Vega and Vega Lite website for details, but I was really interested in this approach, and a few years ago I was at a workshop with Brian Granger, who's on the Jupyter project, and he had this idea of creating a Python wrapper for Vega and Vega Lite, and so I jumped onto his idea and have sort of ran with it since then.
So part of this Altair project involves having this Python wrapper, of course, to be able to interact.
Yeah, so the reason we wanted the Python wrapper is because JSON is nice and compact and expressive, but nobody wants to type JSON code, right? So I'd much rather compose my charts in Python. So the idea was to build a Python API that mirrors this grammar that's defined in the JSON.
Okay.
And I think my feeling as a result is that it's a very intuitive way to kind of succinctly create exploratory data visualizations. Okay. It has, one of the other advantages is it has this built-in grammar of interaction, which lets you, rather than saying like having a few different chart templates that you can use, like this is a chart that has a box that you can drag over it, things like that. It composes different interactive elements and lets you create a whole bunch of different charts. There's really huge possibilities there, and so it's been a fun project to work on, and I've been spending a lot of time kind of trying to support user questions and things like that, and it seems to be getting a bit of a toehold in the data science community.
So when you talk about this grammar and all that, I think always about the grammar of graphics and the I forgot the name of
the ggplot.
The ggplot, and ggplot and the author like having this fluency when you write. Is this somehow going in that direction as well?
Yeah, I think it's both ggplot and Altair are based on this idea fundamentally that you're using a grammar of graphics in order to express things, and it's declarative in the sense that you are kind of talking about relationships between data variables and things you see on screen, and the rendering kind of takes care of itself. Other libraries that people are used to working with are more imperative, where you're kind of saying you're controlling exactly what's happening on the graph, controlling this is what the axes should look like, this is what the line should look like, and the thing that I think people miss in imperative visualization languages is kind of the fluency of being able to iterate quickly, because you have to think about so many details.
Yes, so much like Python allowed us to write code that does stuff and not think about the intros of Python. I guess this is the same direction. Like I just want a graphic. I don't want to learn about the attributes of an axis.
Yeah, exactly.
Yes, great. So how is this the output of this library? Is this based? It started as a JSON thing from a group that worked developing D3. So I guess it's web oriented and it's beginning.
Yeah. So Altair, literally what the Python package does is it just spits out a JSON that describes a chart. And then from there, we have plugins for Jupyter Notebook or Jupyter Lab or other platforms that know how to take that JSON structure and render it into a visualization.
Okay.
So the visualization part all happens in JavaScript. The specifying of the chart all happens in Python.
Okay.
And you need some kind of bridge in the middle, and the Jupyter Notebook is a great place to have that kind of interaction between Python and JavaScript.
Sounds like a great project. I should look more into it.
Yeah, you should.
When I have some time. What's the future direction of the project? How has been the adoption of it? Have you seen any particular group that is like taking more on it?
Yeah, there's a lot of interest and a lot of initial adoption. I think one weakness of the Altair library now is that as data sets get large, it kind of slows down. And the main reason for that is just the data representation. Because right now, to create a chart, you're creating a JSON object that contains all the data. So if you have 1 million rows of data, this becomes a big JSON blob that's kind of unwieldy and a little bit slow to visualize. Fortunately, I've been working with the people behind the Vega and the Vega Lite library, who are still at University of Washington and elsewhere, MIT as well. And that group is starting to dig into some solutions to the scalability thing. So I think as Altair moves forward, we're gonna see some improvements on the JavaScript side and improvements on the data representation side that are really going to address the weaknesses right now. Right now I can't recommend it as a library to replace every visualization use case you're going to use in Python. It scratches a few different itches, but I think as these representations improve, we'll be able to do more.
That's Altair. I'm just working out from the other things that I know. I know that there are packages that are more focusing in rendering like large data sets of data and doing it gracefully. Like I believe data shader and Hololens and all these packages that Anaconda has developed. Like some of them have this aspect. Like, have you seen any intersection or places where?
Yeah, there's. That's a good question. So, in theory, what I would really like to see is this Vega-like grammar become kind of a lingua franca of visualization to pass information between different programs. And it's a technical challenge, but it's not a theoretical challenge to say have a Matplotlib renderer for Vega-Lite or a bokeh renderer for Vega-Lite. And if we can do that, then that would be kind of my dream with this thing, to use this declarative API to build charts in an intuitive way, and then have them render on these different backends that are suited to maybe to big data or suited to generating PDFs for publications or suited for embedding on the web. It's a lot of work there, but I think it's something that could happen if we keep pushing on it.
Okay, great. Is there any conference in particular where this visualization specific things are being discussed that are maybe not in the Python world?
Yeah, there's a couple in the visualization world. I'm going to forget the names now, but my colleagues who work in visualization research are often going to these. OpenVisConf is one that I've been to. I think there's an IEEE Viz, and there's this whole community of people who think about visualization as their research. Yeah, and it's so cool to talk to folks who have thought that deeply about a subject that most of us in the data science world just kind of take for granted.
Yeah. So you have written, I believe, 3 books. Recently, I believe is one on machine learning applications in astronomy.
Yeah, that was a few years back.
That's like 2014, I think. There you have another one on data science.
Yeah.
And the other one is on?
Is kind of intro to Python for scientists.
Python for data science. Okay, great. So should we expect any book soon coming into the future regarding visualization?
No, I don't think so. I'm taking a little break from writing right now. I enjoy writing, but it's taking on a project like a book is very. I found it to be a little bit overwhelming because it sort of, for me, it kind of took over my life, and I couldn't really relax until it was finished, and it took a year and a half. So a year and a half without relaxation is tough.
Yeah.
So I think if I'm in another place, another season of life, I might go back to writing, but not right now.
Okay. We will all expect that.
Yeah.
With a lot of anticipation. So now back to what you're doing these days. You recently transitioned from working in the Washington University to another position more in software engineering.
Yes, I'm a full-time software engineer now, which is it's wild. I started out thinking I was going to be a physics professor, and just along the way met different opportunities that led me to where I am now. The transition out of academia was interesting. I had taken a position in 2014. I took a position with the eScience Institute that was deliberately kind of a hybrid position, doing academic research, but also writing software and focusing on the software that supports the research I was doing and that other people were doing. And over time, over that 5 years, I found myself spending more and more time on the software engineering and less time on the research for 2 reasons. One was because I felt the software was where I could make the broadest impact. If I write an effective and efficient tool for AstroPi, then there are hundreds or thousands of astronomers that are using that, and I can see the results of that in a lot of people's work. And the other reason was I just like software engineering. I like building these tools and learning about these different algorithms and figuring out how to scale the processes we're using on small data to larger data sets. And so by the end of 4 or 5 years at eScience, I was writing software full time and starting to think about what the next steps were. And I wasn't really, because I was focusing so much on software, I wasn't really preparing myself for the classic academic track.
Okay.
So I started looking around to think about where I could learn more and develop these software engineering skills, and eventually decided that joining a software engineering team full time would be a place where I could learn a lot. And it's been phenomenal. I'm writing a little bit of Python, but also writing a lot of other languages like JavaScript. Learning about the kind of the workflows that professional software engineers are using in industry, which some of those trickle back into academia, but it's really expanded my horizons. So I think it's been a good move.
It's glad to hear. So there is like a middle ground, like with software engineering software, there is more and more use of it in academia. And And I remember that this journal was created like a year or two ago, like
the Journal of Open Source Software
or something like that. Yeah. So like, have you published anything there? Have you had any connections there or looking into?
Yeah, I was on the editorial board for a while of the Journal of Open Source Software. It's just a phenomenal group of people that are doing great things. I have a couple papers published there.
Okay.
I think it's really doing a great thing to bridge the gap between kind of the classic academic classic things you need to do in academia. Get citations and publications, and the work that needs to happen in so many fields of writing the software. And there's really a challenge there, and I don't know. Maybe someday I'll end up back in that world. I do miss some of the research aspects. I miss the astronomy community that I'd been working with. But we'll see. One thing my career path has taught me is that I have no ability to predict anything.
Okay, so this next question probably is out of line, but I was going to ask you, like, what do you see in your future? Like, what are going to be the next 5 years for you, probably?
That's a good question. I mean, right now I feel like I'm learning a lot, and I feel like I'm enjoying the work that I do, and that might continue, that might change, and we'll see in a couple of years what the opportunities are.
Maybe in 5 years you're switching gears again.
Yeah, maybe
we're
so.
Having a new conversation around that.
Yeah.
Okay, Jake, thank you very much. So I guess just to wrap up, I would like to ask you if you have anything you want to say, anything you want to share with the bigger PyCon Colombia community that will be at some point watching this, maybe to inspire the astronomers that are under.
Well, I just gotta say I've been so impressed with the group here and the community here, and all of the work and the opportunities that are happening in Medellin and in Bogota and kind of the broader tech community in Colombia, and I'm really excited to see what comes out of it.
Yeah.
It seems like you're doing a great job kind of organizing this community around PyData and PyCon and other local conferences, and I hope to visit again someday.
Yeah, there's so much work to do, so we will be really thrilled to have you back again. So thanks again, Jake. Hope to see you again soon.
All right.